Our last presentation is from Marc Drainville. He's a principal with GHD Inc. in Hyannis, Massachusetts. He's a professional engineer and board-certified environmental engineer. His specialties include wastewater planning and design with emphasis on nutrient removal and advanced wastewater treatment.
So I chose the title for my presentation because it had a little bit of an exotic ring to it. How are we dealing with PFAS throughout the world? But this is a worldwide issue, and you'll see there are some common solutions, whether you're dealing with this issue in Australia or California or Connecticut. If I were to subtitle this presentation, I would call it PFAS. What is it? Where do we find it? Why do we care? And how do we remove it? So that's pretty much what I'll cover today. So PFAS, I'll start with the what is it. It's either a perfluorinated alkyl substance or a polyfluorinated alkyl substance. That's why it's abbreviated to PFAS. It's not naturally occurring. It's something that's purely manufactured. An interesting aspect of this is it's hydrophobic and hydrophilic, which makes it a little bit difficult to target a chemical to help remove it. And it's resistant to microbial, chemical, and photolytic degradation, which makes it very persistent in the environment. The two parts of PFAS, poly and per, they're both a little bit different. The polyphos could be transformed into the perfos, and the perfos is actually the more resistant form of PFAS in the environment. So the uses of this contaminants, you find it in food packaging and dental floss. I'm not sure how many of you saw this, but I think it was January 2nd of this year, there's an article that came out that PFAS was found in Oral-B dental floss. I mentioned this to my office when I read that article, and one of the guys came up to me and he said, "Mark, I can't stop using dental floss." I'm not asking you to stop using dental floss, it's just one kind that has it, but useful to be aware of that. Non-stick cookware, if you've heard of PFAS, you've probably heard about it being in that. Firefighting foam, that's a very common place where you find this too. Occurrence and detection in the environment, fire training centers and airports, manufacturing industries, landfills, and obviously you'll find it in wastewater effluent and in biosolids. So there's a whole slew of manufacturing products that contain this product. Military vehicles, firefighting equipment, pesticides, and then different places that we're finding it in the environment. So why is it a concern? So it's widespread. I attended a conference about 6 months ago, and a member of the Silent Spring Institute gave a presentation on PFAS. And she talked about some studies that they had done, and they were finding PFAS in a remote island found between Iceland and Great Britain. And it's an island that really has very little contact with the rest of the world, but yet they're finding measurable concentrations of PFAS there, coming from the atmosphere, atmospheric deposition, as well as from the ocean. It's highly persistent, bioaccumulative, and then mounting evidence of health concerns. So the health concerns that we know of are it's been linked to liver damage, immune system damage, developmental issues, and cancer. I'm based in Hyannis, and there was the water system in Hyannis had a PFAS hit recently, and there was some suspicion that the PFAS had been in the water for some period of time. It's unfortunate because some years ago that system was treated for something else, and they went through a treatment process and then found PFAS in it later. Recently there was some articles out about they're going to be testing the kids in Hyannis for in this case specifically for inoculation, inoculation's not really working very well for them because of the exposure to PFAS. So there's a number of different impacts you can have. So this product's been around for a while. It was first developed in the 1940s. I'm not going to hit all of the highlights of this, but one thing that's interesting is that the health effects were known back in 1960. And since then, there's been a slow realization of the problem, and it's been taken out of some products over time, but it's still very prevalent in our everyday products. You know, so what's happening recently? I mean, there's although I would say this is still somewhat emerging, there's still standards that are falling into place, but there's certainly much more awareness of this being an issue. And I mean, I think you all probably know, I mean, PFAS is one of millions of microconstituents that are present in the environment and in wastewater effluent, but it's one that's receiving attention now. So I am going to talk a little bit about some work we're doing in Australia, and I'll start out by just doing a little bit of a comparison to some of the standards worldwide. There are many different parts of PFAS, and I'll show there's at least 10 or 12 different constituents that are measured in that class. As far as setting limits, for PFAS and PFX, it's very comparable. The Australian and the U.S. limits are very comparable. But when you look at PFOA, the limits in Australia are quite a bit higher, so our limits here are significantly lower. A little bit of history for here in the U.S. Back in 2009, there were some advisories issued for PFAS and PFOA, 200 to 400 nanograms per liter, so quite low. In 2016, those limits were lowered to 70. And what we're seeing now here in Connecticut, you could see there's 5 constituents that together need to be 70 micrograms per liter or less. Massachusetts has added one additional item to that, and still it's a sum of 70 or less as a guidance for drinking water. So can we take PFAS out of the water? We can. One of the things that you have to be mindful of, though, is what's the state of the water that you're treating. It's very likely that you're going to have to put in some kind of pretreatment, whether you're trying to treat drinking water, wastewater, or an aquatic system, which I'm going to talk about later. Some kind of pretreatment is going to be needed because the equipment that you need is among the most complicated and sophisticated to take out PFAS and other microconstituents. Some factors that come into play when you're looking at a treatment process. There are transformations that can occur when you're looking at taking out microconstituents. There was a Water Environment Research Federation study that was done several years ago where they were looking at taking out different microconstituents. And what they were finding is, depending on what process you use, you could actually create a worse constituent than what you're trying to take out. So you have to be mindful of that when you're looking at a process. And pretreatment is very important also. So there's a lot of different remediation technologies out there. Some of the things that you see with an emerging treatment is that you have emerging technologies, and we saw this with nutrient removal when that was coming out, and you tend to have regional processes that will come about, and as time goes on, some of those will shake themselves out, and you'll end up with a nice core of products to use. When you're looking at a solid product like soil, you're probably looking at incineration in that case to take out PFAS. When it comes to water, you're looking at, again, some very sophisticated processes. Granular activated carbon, ion exchange, nanofiltration and reverse osmosis. The list that I have to the right are all kind of regional types of processes that are kind of still in the process of being understood. Coagulation is a pre-treatment process that is commonly used when you're trying to get out microconstituents, and it's really used as a pre-treatment for reducing the levels down so your primary or your last process and more expensive process can take out just the bottom end or to polish at the bottom end. So this is black because it's kind of a gloomy slide, gloomy news. So I'll just explain what this is. This is looking at a bunch of different facilities throughout the world and what they use to take out PFAS. The very dark or the very black is the more efficient at taking out PFAS, and then the gray is the bottom end, not very effective at taking it out. And you can see that the nanofiltration and reverse osmosis, they're very effective at taking out PFAS. The next level would be granular activated carbon, and then the next step below that would be ion exchange. The other processes up there perhaps could be used for pre-treatment, but you're looking at things like coagulation, which are really seen more as a pre-treatment step. Oh, and one thing I didn't focus on is this is all the different types of compounds that are kind of targeted in the class of PFAS. It's about 10 or 12 up there. So this could be a presentation unto itself, but these are different technologies that are commonly used to take out PFAS or even other microconstituents. They have different levels of effectiveness, but they have some serious downsides. Probably the more effective one at the top, reverse osmosis and nanofiltration. What blows your mind with those processes is you end up with a reject water, and those of us in the wastewater field, don't really think that much about it, but there's a tremendous amount of reject water you can get from a reverse osmosis system. It could be as much as 40%. And when you're a water plant, that's fine, but when you're a wastewater plant, you don't have anywhere to send that. Granular activated carbon, again, effective, but you have a waste product that you have to get rid of there. Ion exchange also has it's a brine or a reject water that you'd have to deal with too. So, there's some serious disadvantages when it comes to these treatment processes. So the emerging technologies in the field are looking at coagulation, biodegradation, and oxidative reductive technologies. I'm going to talk a little bit about the first two, coagulation and biodegradation, but I'll tell you that what we're finding is that those are more effective as a pretreatment step. So the project that we're currently working on is a site it's in Australia, and it's trying to drop PFAS levels from around 0.3 to 1.8 down to, initially it was 0.29, and the level dropped to 0.13, all micrograms per liter. And this is a product that had required some pretreatment. And we started out looking at a jar testing, adding a coagulant, a chemical. This is not uncommon as a pretreatment step, but we looked at it to see how effective it was at dropping the levels of PFAS down to where we needed them to be. Those of you familiar with water treatment, this is a very common, doing jar tests and trying to figure out how coagulation and flocculation, how effective it will be, and that's essentially what was done with this trial. What we found is that it was effective at taking the levels down for various PFAS compounds, but we couldn't get it down to the levels that it needed to be at. But we did determine that it could be used as an effective pretreatment step. We also tried a biological treatment, again, just at a lab scale, just like the jar testing. And this was a little bit less effective than the chemical additive that was done in the previous example. But it was effective enough that it could be used as a pre-treatment step again. But neither of them were determined to be effective enough to meet the 0.13 micrograms per liter. The advanced oxidation process is something that's going to be tested soon. And this is actually one of the processes that in the WRF study that I referred to earlier was found to potentially create even worse compounds than what you're trying to remove. So that's something that we have to watch out with in looking at this. So just a little summary. Find this product in everyday life. It's in Scotchgard, it's in Gore-Tex, it's in, many things that you may not even realize. It's persistent in not only the human body, but in animals. It's bioaccumulative, many health concerns. How do we remove it? The most effective means, granular activated carbon, ion exchange, and reverse osmosis. And chemical and biological treatment can be effective as pre-treatment steps to help save on some of the O&M costs and maybe save on the size of your final step, but they're not effective as an ultimate step. So, with that, I'd be happy to take any questions. Yeah. I'm sorry, I'm having trouble hearing you. That's a good question. I don't know that it has a. I don't know that it has a half-life. I haven't heard anything about that. Just that it's persistent. So sorry, I don't know that. I don't know that I've seen anything with regard to where it's more common. I don't know that I've seen that. I mean, I can tell you that, I'm sure it's, if it's in surface water, it's coming from atmospheric deposition. The risk with groundwater is certainly, if you have any kind of a wastewater discharge that's going to the ground, you could introduce it that way. I haven't seen where it's more common, though. I haven't seen anything related to that. So. Yeah. Yeah, I actually, Bill Brink just mentioned that to me this morning, so that's a kind of a new issue that for me too. I mean, this is kind of somewhat of an emerging thing that we're all just kind of grappling with. It's I think we're going to find it in more places than we expect. So I have not I've not heard of that. So it's a good question though. So with reverse osmosis, typically that's a water treatment technology, and the reject water would go to the wastewater facility. Okay, so in Massachusetts and some other areas in the country, they target total organic carbon when you're discharging wastewater to a groundwater supply that's for an aquifer. And so we've explored, that as it relates to a wastewater effluent, but it's hopefully not that common. I mean, many of the discharges to the rivers and the oceans may not face that kind of need to take this out, So, but yeah, it's tough. I mean, we ended up gravitating towards activated carbon because at least you can ship that out somewhere, And that carbon can be regenerated, or disposed of, so. Yeah. Yes? So it is, but I wasn't talking about soil today, but I understand that is what they use in soil. As far as sludge goes, I'm not as familiar.